Hello friends, I'm back with another video, the new component. So in this video we understand what is an LLM agent. So what's the difference between an agent and an LLM and a reasoning core, how do they interact, and how it helps in designing an enterprise AI agent. So let's get into it. Okay, let's start with episode 2, the new component, what an LLM agent actually is. Before I jump to the first slide, just be very careful when I say LLM agent. Many people think that okay, there is one component called as LLM agent, but in reality, these two are different components, LLM and agent. How it is different, we'll understand as the video progresses. So let's move ahead. Okay. An agent is a distributed system. We saw in our last episode also that the agent is doing a lot of stuff. It is basically connecting to a memory, an API, a database, external calls, and a lot of actions it is performing. This is the differentiator basically between a chatbot and a agent, right? But be careful with this diagram, it is a bit deceptive, okay? Because here what it says that there is a reasoning model at its core, okay? So you need to understand this English is a bit deceptive, because the reasoning model will never perform any of these actions which are being shown. Okay, reasoning model is a LLM, a large language model, which we will understand as we progress. But the agent is different from a reasoning model. I mean, we don't come to know while we are doing that with ChatGPT or Claude or Gemini, because we are just interacting with one single interface. But here, for our purpose, where our goal is to design an enterprise AI agent, do remember that the agent is a separate entity over here, okay, which interacts with the reasoning model, and then basis that it may then take actions. Okay, so this is one important nuance I want you to remember. Sometimes it is, it is helpful when for learning, basically when you start with some level of confusion or confusing uh, diagram or presentation, and once the confusion clears, the concept gets internalized into your mind. So the reasoning model will never take an action, okay, the agent will take an action. So remember, the agent is a distributed system, but it is definitely different from a reasoning model. Keep that in mind. Okay, so coming to the basics. So what is an LLM? A large language model. Okay, many times people get confused that okay, they hear the word LLM model again and again, but they're not able to actually comprehend and define it properly. So here's a very basic definition again. LLM is nothing but a program that has learned from a large amount of data and patterns. Okay, again a jargonish definition, but in simple words, a large language, you need to focus on the word language. It's a large language model. That means it can understand human style language, okay, and at the same time it can actually give you answers in a human style language, right? So the important part to focus is this: it can understand and generate human like language. Okay, that's the important part which you should be remembering. Okay, so that's the large language model, and this language model, as we learned last time, that it has been trained on large amount of data and patterns, which is your libraries, books, novels, research papers, websites, URLs, etc. Okay, so how it generates, this is very simple. We simplified in the last few videos that it is the next best predictable word generator, right? So I gave you some simple example like twinkle twinkle little, and if it's a dash over here, it will easily predict star. The cat sat on the mat, right? But this prediction happens at a very high speed. That is the engine underneath which performs these actions, right? So LLM is nothing but which can understand language, and which can output the answers basis the next predictable word which it can see or which it can figure out. Okay, but you may be thinking, okay, you said that it's a conversational chatbot, or it predicts the next word, but nowadays the modern LLMs are doing much more than that, right? It can write documents for you, it can write emails, it can answer questions, it can hold conversations with you, right? Now how is it all happening? Now this is because of the agentic format of LLM. So it is not LLMs alone doing this. LLM, again I'm repeating, it's a large language model which has a specific task. Okay, it basically has a reasoning core, and it has learned from a lot of data patterns, but when it comes to action, the action will always be performed by an agent. Now how that action is performed and how LLMs are different from agent, we will look into it in a bit. Okay, so the simplest frame again for an LLM is, uh, you give an input to the model and it will predict an output. So input is always text. It goes into the LLM, it predicts the next word basis the patterns and data which it has learned, and it will give you an output. Text goes in, text comes out. That is the whole interface of an LLM. Okay, now the key distinction. Okay, the model itself doesn't do anything, as I told you right over here. When we looked at these examples, write documents, write emails, answer questions, whole conversations, this is not the model doing it. This is some other entity which we are calling it as an agent, which is doing all this stuff, right? So the model doesn't do anything. It always takes input text and it generates output text. That's all it does. Now how do you differentiate the model versus the agent? An agent in and of itself is a whole system. This you need to internalize and memorize or comprehend, so that you are always able to differentiate what an agent is and how it is different from a model. Here in this diagram you can see that the model is only this much of the part, right? But if you combine this model with memory, tools, databases, and APIs, and someone connecting to all these entities and performing some action, that is called as an agent. An agent is someone, some entity which can act, which can take an action. So the agent, as I told you, in and of itself is a whole system. The model will always guide the agent. It will always output some text. Based on the text, the agent can take an action. For example, if you give some kind of a goal to an agent, the agent will not be able to perform any action on its own. It always will go to the model to ask for the next action to be performed, because the model can do the reasoning part and give a response to the agent that, okay, you go and connect to the memory, you go and connect to a specific tool, you go and connect to a database, you go and connect to an API, right? So that is the difference between a model and an agent. And this is very important from a designing perspective, because while you're designing something like a enterprise AI agent, you need to understand that how this marriage, this handshake between the model and the agent should happen. Okay, so don't be impressed too early. What does this mean? Let's say you're buying a car. So this, I missed the car part over here. This salesman is of a car salesman, right? So when you're going to buy a car, the salesman will talk about the color, so elegant, so fancy. It will talk about the touchscreen inside the car, maybe, which gives you the navigation part, maybe speaker device. A radio, a sound, then it will talk about the discount, right? Okay. Same way, if we relate to ChatGPT, if you ask a question, you get a good answer and you are impressed. Yay, what an answer I got! And in like uh, 10 seconds. Okay. And now that is related, that is what is happening in a showroom as well. As I spoke about the car salesman, but there is a hidden reality to it. The color, touchscreen, and discount are actually not enough for you to actually decide whether this car is helpful for you, or this car will actually satisfy your need or not. So, what do you need to ask instead? The question that actually matters: what mileage will it give, right? The running cost every day. If the car is very fancy but it gives you a mileage only like 2 kilometers per liter, then you will soon go bankrupt, right? You may not be able to afford, or even drive the car. Will it survive Mumbai traffic? I'm taking the example of Mumbai because I stay in Mumbai, of course. So in July and August, during heavy rains, during heavy traffic, will it survive? The real conditions, not what is written on the brochure. What is the maintenance? What it costs you over the years? If there is a lot of maintenance, and if it is, of course, not free, then again it will be a very huge cost burden. Sorry. It is not about what the model already has. This is the important point which you need to remember. ChatGPT already has a lot of stuff inbuilt into it. The model is ready, but whether that model is enough for you, for your enterprise AI, or maybe your custom AI which you're building, or whatever model you're using. I just use the ChatGPT example to relate. But let's say you're using any model for your enterprise AI design, and that model, whether it is already ready or not, that you need to decide, because it basically boils down to the fact that it should be custom built for your use case, for what you're building the AI. Okay, so it is about what you need from it, and whether it can deliver or not. Now, again, going to some basics. I keep harping on the basics. Basics are very important in my view. If your basics are not clear, then you will not be able to design anything advanced. That's the important point. Always I would recommend everyone to remember. Okay, some basics about the reasoning core. Three properties which you should know. The reasoning core is stateless and slow. Two properties we are discussing over here. We'll look for the third as well in a bit. Stateless, it maintains no state at all. What it means that if you ask the same question again later, you can get a different response. For example, uh, it has been programmed in such a way with some amount of data, that data is not changing. That I'm talking about the training data, not about some persistent or dynamic data being fed. It's about static data which has been fed for training, that is not changing. That means uh, you know you if you ask a question right now, let's say if you ask that uh, maybe uh, what are the phases of the moon, right? It can give you the phases in a particular sequence with some description of the text, like there is a crescent moon, there is a full moon, there is, let's say, what we talk about amavasya, right? But then if you ask the same question again, maybe after one day, it can give you the a similar answer, but in a different format, right? It may talk more about the crescent moon, or talk more about the full moon, right? So there are chances that you may get a different response, because it is not saving its own responses which it has given to you the previous time. It just functions like a static engine. Okay, now it is slow. Slow means it will not respond to you in milliseconds, right? It takes seconds, sometimes 10 seconds, 20 seconds, and longer still for complex responses. So for example, you must have seen when you give a complex question to ChatGPT or Claude, it goes into a thinking mode. You see that thinking text which says that, okay, it is thinking on this complex question to give you a proper response, right? So it's always 10 seconds, 20 seconds, and longer for complex responses. So for the reasoning core, we discussed two properties: stateless and slow. The third property is the important property while designing. uh, it is metered in the sense you cannot just keep on asking questions, or maybe trying to get some output out of the reasoning core for infinity, right? Because the responses which you are getting from the backend are using high-end GPUs. It is using a lot of heavy compute, and it has to be constantly maintained, right? It cannot be provided unlimited, right? This is where when you um go into a context window, a chat window, and you keep on chatting question after question in the same window. After some time, it says that you are about to exhaust your limit of tokens, or you have exhausted your limit, right? So that is the reason the reasoning code is always metered. uh, okay, the obvious objection which can come, you may say that if it is stateless, how does ChatGPT remember, not just inside one chat, across separate chats too? Because we have seen that, in fact, I have seen it many times. ChatGPT does that. A question which you have asked from ChatGPT, maybe before uh, 2 months, 3 months, it can again come up with the same information and tell you, okay, you had asked me, or I know that you have so and so maybe condition, or you are so and so. Based on that, this is the response, right? So, for example, uh, 6 months back, I had told ChatGPT that I am an enterprise architect. Okay, and many times while he's giving me answers, okay, nowadays he says, since you're an enterprise architect, you can do this and this, so and so, right? So where does it come up from? That means there is some kind of persistent memory which it is maintaining, right? So across chats, how it is maintaining, you mention a fact, as I told you, I am an enterprise architect. It stores in a separate memory, okay, but in this memory it will not store your entire conversation, entire chat, right? Only relevant information. It can truncate and summarize and keep it, because it feels that, okay, this is a factual information and persistent memory. So this is adopted by some of the models. I can see ChatGPT and Gemini do this extensively, but in Claude, I haven't seen that. In fact, in Claude, in the same project, if you switch the context window also, it does not look into the other context window of the same project. I mean, that is the behavior which I have seen, but that's okay. But you get the idea, right? That there is a persistent memory in which it stores only uh, relevant information or factual information, which can be recalled months later also. Okay, but yeah, do remember, not every product does this the same way. Okay, inside one chat, how it happens, this is an interesting stuff, where how LLMs behave in a specific context window. In a single chat window, these LLMs are very strong, believe me. So how they operate is that, let's say you open up a chat window, you asked a question one, okay, so it gives you a response, answer one. Then the turn two, you again ask a question two. When you're asking a question two, what it does is that it actually, the chat reads your question one again, your answer one again, and your question two again, all the three again, and then gives you a response like a answer two over here, and then forgets everything. Again, when you answer question, put a question again in the same chat window, it will again read the question one, question two, answer two, and question three, give an answer to question three, and again forget everything, right? So that is how things work in a context window. But the problem is that, because it has to reread this stuff every time you put a new question, this takes up your context memory, right? In a few videos back, I explained you the concept of tokens. This is where the token limit comes into picture, because any text, whether it is question or answer, that text is converted into tokens, and this tokens has a limit for your context window, right? Where if this token is expired, let's say you're, as part of your questions, you're feeding a lot of documents for the model to read, then every statement in that document also will be broken into tokens, and those tokens will consume memory, and memory consumptions means it leads to compute consumption, right? That's the reason it is very important that while you're designing it for your own enterprise, you remember this fact about the tokens and the limits, and how these question and answers will be processed. We are talking in terms of question and answers, but it depends upon the use case what you're trying to build. Okay, the ceiling, the context window has a limit. As I told you, tokens are what get used and held for a chat. Keep chatting in one window and it fills up. Eventually you get a warning or you are stopped. So what does this mean for us? The concept of tokens and the limits. Memory becomes a design decision. When you're designing an enterprise AI, you should always think of the fact that what it remembers, how it remembers, what counts as relevant. As I gave you the ChatGPT example, that persistent memory, what is relevant? I mean, ChatGPT does not store everything which I talk, which I chat with it, but it does. It did store the enterprise architect fact about me, right? Why did it do that? That relevance has to be there for you also, that when you're designing the memory, you should know that what all things have to be captured in persistent memory. So how this memory is designed, then again, post the memory, if you're trying to connect to a database, what comes from the database, what comes from the AI, right? Maybe this has to be API. What comes from the API? All these decisions matter, and all of them are yours while you're designing an agentic AI. Okay, how the agent and LLM actually talk? This is the interesting part which we are waiting for till now. Okay, let's see. The basic exchange: goal out, instruction back, action taken. So it all starts from a goal. This is our use case, what you want your agent to do. Now the agent has come into picture. We talked a lot about LLMs, reasoning core and models, some part about agent, but then here is the agent in action. Your agent is nothing but your code. Okay, the agent gets a goal, it sends the goal to the LLM. Here, LLM being the reasoning model, the boss, the thinker, will actually decide, okay, what needs to be done, and it will send back a response. Okay, do this, do that. That means the code will then actually connect to the API, databases, Kafka, other interfaces, etc., to take an action. So your agent in this case is nothing but your orchestrator. Your orchestrator is your code, your program which you have written. Okay, and you have married this orchestrator to your LLM. Again, the flow, your input arrives at your agent. Agent asks the LLM before it acts. LLM reasons and returns the instruction. Agent executes. Everything happens. Everything real happens over here. That means the execution part, as I told you, this part happens at the agent level. So, coming to the example which I took in the last video, what the agent actually executes. This is only the execution of the agent, but how it is married to the LLM we'll look into a bit. But before that, what the agent does in a fund transfer example, it can call a database, it can check the limit, it can check the balance. This is the sequence of flow, by the way, for a fund transfer from a from to account. For example, if you're doing a fund transfer, you may need a from account, you may need a to account, you may need a amount. Okay, uh, maybe 2000. Okay, so to this transaction, how the flow goes is that it will call the database, it will check the limit, it will check whether it has enough balance, then it will call the core banking, debit one account and credit another, then it will call an API to send an SMS, then it will send the email to a customer by calling an SMTP connector. In the end, it can actually report the completion to the model. Okay, now here comes the important part, loop. This is also a design decision which has to be taken very meticulously. This is the interaction between your agent and the LLM, right? The marriage which I talked about. Let's see. So same example, fund transfer back and forth, but remember this is a hypothetical example. This is not reality, but still for your understanding and explanation, I am giving this example. So the agent gets a goal, right? It goes to the LLM and says, okay, I have a goal to do a fund transfer. LLM says, please check the balance and get back to me whether it has sufficient, the account has sufficient balance or not. Okay, starting again for this fund transfer example, to show you the loop, midway my pencil charging gave away, so I'm just starting it again. Okay, so let's look at this example of fund transfer and how a loop works. As I mentioned, it's a hypothetical example. This is not exactly how it works, but it will give you a feel how the agent and LLM interacts, right? So let's look at our goal. Our goal is to do a fund transfer. There is a from account. Okay, there is a from account, to account, and maybe some amount to be transferred. This is a goal which has been given to the agent. The first step, it goes to the LLM with the goal. LLM says your first step is to check the balance. Agent goes and checks the balance, gives the response back to the LLM. LLM says balance is good, now check the limit. Agent goes and checks the limit and gives the response that limit is so and so, and LLM says the limit is fine, now go and do the debit. Agent does the debit and says that debit is through. The LLM says okay, debit is through, now do the credit, and so on. So every result is carried back because text is the only input the model has, right? Okay, so the agent is continuously giving the inputs to the model with the responses, and the model is doing the reasoning part and giving the responses, right? Now this is again a hypothetical example. In a real banking scenario, the agent wanted, once it gives the goal to the reasoning model will look at all the parameters, okay, and give the instruction once to the agent where there will be a sequence of activities already which the agent needs to be performed. No back and forth is required for so many activities. Okay, keep that in mind. As I told, this is not how it actually works in a banking scenario. These sequences are predefined. The agent does not need to go to the model again and again. Okay, so the loop shows up where judgment is needed. So why I mentioned this, or why I put this slide over here is that, so let's say the instructions are there in the banking example, the agent is going to execute a lot of stuff. But in the parameters, let's say if I go back to these parameters, there is one parameter which says time of transfer. Let's say it's 3 a.m. in the morning, and this 3 a.m. The customer has never done a transaction at 3 a.m. in the last 6 months or 1 year, right? Now this can get flagged. I mean, this relates to a fraud check example, but I'm just taking this here so that you can understand that one of the parameters that this transaction is trying to get executed at 3 a.m. in the morning, the reasoning model can actually catch this. The LLM can catch this and see that this is something suspicious, and it can add an additional step over here. Before the check balance even starts, it can say that throw additional authentication to the customer. That means the agent will actually go back to the customer and say, give me additional OTP or answer a security question, right? Okay, so that can happen. So that is the advantage of having a reasoning model. This is a very simple example which I am giving you, but the reasoning model can have lots of data and lots of parameters based on the training which you have done for that model with respect to this use case, on which it can decide what instructions have to be passed to the agent. Okay, so I hope I was clear. So an extra step is needed. It can insert an additional check into the fund transfer if it finds something odd or suspicious. Okay, moving ahead, this is the last slide. I just wanted a quick recap. Recaps are important, right? So let's retrace the journey. What is an LLM? A program that predicts the next word. Basically, we know by now, watching all these videos and so many repetitions. A model does nothing. No action is taken by a model. It is just text in, text out. That is all. Model is not an agent. Okay, a component versus a whole system. As I told, an agent is a whole system. Model is just a reasoning core. Uh, Ask the right question, right? The car analogy which I gave you, right? Instead of the color and the discount, the important part is the mileage and the maintenance, right? Maintenance. Okay, The reasoning code is stateless, slow, and metered, that you need to keep in mind while you're designing it. The memory is yours, you design it. The model does not hold it. You have to design your memory specifically, as we saw, right, where the persistent memory, the context memory, how it has to be designed. Agent and LLM talking, how interaction happens between the agent and LLM, the goal out, the instruction back, the action taken, and we are honest about where the loop really belongs. Okay, this is how we saw how the loop functions. Okay, 8 steps, one component, and everything you build around it. Perfect. So I believe that uh, we have a good fair idea about how to design the agent. Hmm? So next time somebody says our AI agent connects to the core banking system and processes the transfer, you now know exactly what that means. The model was asked, the model replied with a text, the code read the text, code is your agent, the code decided it was allowed, and the code moved the money, the code told the model it was done as a response. The model never touch the account. Model is only for reasoning. Okay. Okay, so just to keep our eyes on the prize, what we are doing, I mean, a lot of uh, lot of text, lot of presentation, lot of talk, but we should not uh, you know take our eyes off the actual goal which we are towards. We are building towards one thing, which is an enterprise agentic AI, right? A working agentic AI system for an enterprise. It's not a demo, which nowadays many people are doing. Banks are doing pilots, but not those pilots are actually not surviving in production. But we want something to survive in production, audit, and a regulator. So every episode adds one more piece of that system. This episode, you are here, the component, the LLM, the marriage we discussed in this episode. So stay with this series, and you'll not just understand agentic AI, you will be able to design one. Thank you. See you in the next video. Hey guys, thank you for watching this video. I hope it was informative for you. And if you like the video, please do like, share, subscribe. Thank you once again for watching. Bye bye.